In this video, we're going to look at direct proportion. So let's look at this question. The weight of a piece of wire is directly proportional to its length. So when you read a statement like that, the first thing you have to do is write down, say W for the weight. When it's directly proportional to, you write K times the other quantity, its length. So I'm going to use L for length. Now they've given me some preliminary conditions. So a piece of wire is 25 centimeters long, i.e. the length is 25. And in these problems, we're always trying to work out K, and the weight is 6 grams. So we need to work out K, so the opposite of times it by 25 is divide. So we say 6 over 25 is the value of K. Once we got K, then we rewrite the formula to include K in it. So we get 6 over 25 multiplied by L. This is our formula we're now going to use. Then it says another piece of wire is 30 centimeters long. Calculate the weight of this 30 centimeter wire. So we just plug in 30 for L, so we do 6 over 25 times by 30. We can do this in our calculator. So we can do 6 over 25 times by 30. That gives me 7.2. So 7.2 grams is the answer. Here's another question. If you want to try the question, you can pause the video and I will go through my work solution. Okay, welcome back. So here we've got a question that states that in a spring, the tension T newtons is directly proportional to its extension X. So the first thing I'm going to do is write down that T is equal to K times X. Then the tension is 150, so you write 150 here. We need to work out what K is. Now the extension is 6, so we can say therefore K is 150 divided by 6. We can work out what K is on our calculator. So 150 divided by 6 gives me 25. So we can rewrite the formula. Therefore T equals, replacing K with 25. 25 times X is our formula. Then it says to calculate the tension when the extension is 15 centimeters. So we can say T equals to 25 times 15. So we can work out the tension here. So we do 25 times 15, 375. So that'll be 375 newtons. Then it says calculate the extension when the tension is 600. So we do 600 is going to be 25 times X. The opposite of times is divide. So we do X is 600 divided by 25. And we can type that in. So 600 divided by 25 gives me 24. So we get 24 centimeters. The next type of direct proportion question is when you have a squared term or a cubed term in it. So let's take an example. So the question says a ball falls vertically after being dropped. The ball falls a distance d meters in a time of t seconds. Now d is proportional to the square of t. So this is a key word, square of t. So when we write our statement, we write d equals not just to k times t, but it's k times t squared because it's the square of t. Very, very important here. So once you've got that correct, then we can substitute the values in. Now, the ball falls 20 meters, that's the distance. We don't know what k is, and the time is 2, so it's got to be 2 squared. So that's going to be 20 equals to k times 4. Don't forget the opposite of times is divide. So we do 20 divided by 4. So k equals 5. So therefore the formula we require is d equals to 5 times t squared. Then part B says calculate the distance the ball falls in 3 seconds. So we say d equals to 5 times 3 squared. So d equals to 5 times 9. So d equals to 45 meters. Then it says calculate the time it takes the ball to fall 605 meters. So we start off by writing our formula. D equals to 5 times t squared. Now d is 605. So 605 equals to 5 times t squared. So now we can divide them. So we can say t squared is 605 divided by 5. And we can work this out here. So we do 605 divided by 5, which is 121. So t squared equals to 121. To get rid of the squared, we square root it. So square root of 121, t equals to 11 seconds. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So this question says, the distance d travelled by a particle is directly proportional to the square of the time taken. So let's write that down. D is equal to k times the square of the time. Okay, so we've got that written down. Okay, so now that we've got the formula written down, we can now substitute the values in. D equals 30. We don't know k, but the time is 40, so don't forget we need to square it. So we can say k equals to 30 divided by 40 squared. Calculator now and do this. So we're going to get 30 divided by 40 squared, which gives me 3 over 160. So the formula required is d equals to 3 over 160 times t squared. Then it says to calculate the value of d when t equals 64. So we can say d equals to 3 over 160 times 64. Don't forget we need to square it. 64 squared. Let's type that straight into our calculator. We can do 3 over 160 times 64 squared. And that gives me 76.8. Then you want to work out t when d is 12. So we say d is 3 over 160 times t squared. Don't forget, given your answer correct at 3 significant figures. So now we can substitute the value in. 12 equals 3 over 160 times t squared. So t squared is going to be 12 divided by 3 over 160. We could type that into our calculator. So on our calculator we can type 12 divided by 3 over 160. So I get 640. So t squared is 640. So t is the square root of that. We can type that straight into our calculator. So to three significant figures is 25.3.